Welcome, everyone. Thanks for taking a seat. It's been a lot of information over the last 2 days, so I'll try to keep this pretty slow-paced and entertaining. So just, take a seat, relax, and enjoy this presentation. So just before we start, I would like to take a second to remember the memory of my former colleague and friend, Guillermo Amaral, that some of you may know. He was a good friend of mine, and maybe he was a good friend of yours. So I just want to dedicate this talk to him. So what I'm going to be talking about today, I'm going to give you a brief introduction about what Bluescape is and why a guy like me flew all the way over from Texas to talk to you about it at Qt World Summit. Then I will actually present Windows Subsystem for Linux, or give you a quick overview of it if you're not familiar with it, and see how it could save you some time the same way it saved us time at Bluescape. And we'll also share with you some of the tips and tricks that helped us during our transition from porting from Linux to Windows, I'm sorry. So quickly about Bluescape. You've likely not heard of it on this side of the ocean. It's a visual collaborative platform. You could describe it as a digital whiteboard for enterprise where you can input and you can add all sorts of content. So it can be, of course, handwritten notes, but you can also throw in images, documents, web browsers, videos, you name it. So think of it as a cloud-connected whiteboard where you can collaborate in real time with either people in the same room as you or people in meeting rooms in different countries, for example. Everything you do is shared and real time with everyone connected in the same workspace or canvas as you. So Qt and Bluescape is a good relationship. I would not call it a love story, but certainly has a special relationship in my heart, at least. We use Qt for a lot of things, of course. QML and Qt Quick, that's what most of our UX elements are implemented with. We use Qt OpenGL for the window management and compositor to composite all these UX elements on the screen and allow highly scalable workspaces with thousands of windows and thousands of objects. We use Qt Web Engine extensively as well for things like WebRTC for our built-in audio-video conferencing, but also for rich browser objects so that our customers can embed. If we have customers that are in website design, they can use Bluescape to get previews of what they're designing, and they can interact with them in real time. We also use it for embedding YouTube videos or rich editing and live editing documents like Office documents and things like that, all through the use of Chromium and Qt Web Engine. We also use dbus. That's a bit more technical detail, but we use dbus for our multi-process architecture. So this is essentially a story about Bluescape started as a Linux-centric project. We would technically ship our appliance, which was like a custom Ubuntu OS, and the app itself was provided with the update mechanism based on Debian packaging, and that's how we would basically deploy our appliances using Linux. Unfortunately, I guess, or fortunate, I don't know, depends which way you see it, but at some point, we did get quite a push for getting our app to run on Windows as well. So I was actually pretty excited about it because I had prepared for that time for almost over a year by making sure that our Qt usage was all over the place so that porting the code was actually, that's pretty much, maybe I don't look exactly the same anymore, but that's actually me there when I got it to run on Windows for the first time. So yeah, getting the stuff to work on Windows was actually just a matter of weeks. But that was not the end of the story. Once I had that proof of concept prototype, we still had many open questions, such as, what about all the third-party dependencies that we have to build as part of our CI and a continuous deployment process, one of them being Qt, for example, but several others, packages that we use. What about all the deployment and packaging we do? Because again, our CI/CD workflow includes building the app, creating the installer, or packaging it as a Debian, uploading that to servers and stuff. So we actually have a sizable amount of shell script, like them bash scripts, that we needed to worry about how are we going to make that transition with the least possible effort. So there are a few options. We've considered a few of them. First option was Cygwin/MSys, but that's pretty much what happened. Computer said no. It would not, literally, on some computer, would not let us install Cygwin at all. I don't know, I still to this day don't know why. Second option was porting our scripts, bash scripts, to Batch or PowerShell. This was my boss's reaction. So when that happened, that was a little bit over a year ago. Entered, really, all the stars aligned at the right time, Windows Subsystem for Linux. This was right around the time that they had made the first release. And so if you're not familiar with it, Windows Subsystem for Linux, short WSL, essentially means native Linux on Windows. So the Microsoft guys literally ported they ported a way to hook up the Linux kernel into the Windows kernel API so that you run native Linux, the native Linux system directly on Windows. And it runs without any recompilation. It doesn't have any, it's 100% identical to the binaries that you get on Linux. All right? It comes through the Microsoft Store, the Windows Store, through several distributions available, Ubuntu. They have 16.04 and 18.04, as well as Fedora, OpenSUSE, and some other more targeted distributions for like security testing and things like that. So it's literally a matter of going on the Windows App Store, click an icon, and you end up with a new icon that opens up a bash shell with a fully running Ubuntu, in my case, system. 100% identical to what you have on a native Linux machine. There are limitations, of course. The main one, I think the most noticeable one, being that it's limited to console mode. That said, of course, when Microsoft announced that, the first thing that people tried to do is see how they could get around that limitation and get graphical apps to run, which you can thanks to the X11 client-server architecture. So you can technically run Linux X11 apps on Windows. You just need to have an X11 server running on the Windows side. And these two will then communicate via name pipes or whatever. So can we, oh, I guess we cannot see this here. I'm just gonna show you a quick example here. So here is my bash shell, which was then added to my taskbar when I installed the Ubuntu distribution. Oh, actually, it would be LSB. Release. There we go. Oh, dash. I forgot. Oh crap! I forgot the option for that now. I'll just give you dash uname. All right. So here it really reports itself as a Linux kernel running on Windows. You have all the Linux tools available. All right. You can do cat. I'm not gonna cat secrets. I know you guys will want that, but just gonna say. All right. Let's just go bluescape.log. All right, and then I can do more if I want. That's it. So really all the environment that you're used to, everything then works as is. So what is really cool about this is, like I mentioned, it's really the native binaries. So if you have, for some reason, a command line tool for which the vendor provides Debian packages or any kind of Linux app, you can, and if it's not available on Windows for some reason, you can literally copy it from your Linux machine into your Windows machine, and it will run 100% the same because it is the same binary, byte to byte. So moving on. I'm now going to show you like how when we got that tool, we were like, okay, what's the next step? And now how do we, obviously we're gonna be able to run a bash script, which is gonna save us a ton of time, but we're still gonna have a few things to think about. Things like, how are we going to deal with the different file systems? As we all know, Linux has ext style with a /root versus Windows, which still has the concept of drives, all that stuff. So that's one thing we still have to think about. And I will also talk later on about how we integrate tool chains, because you still want, in the end, to build Windows binaries, even though you're in a Linux environment. So the first thing you need to be able to do to get productive, there is a little bit of adjustment you need to make in your scripts, is figuring out if your script is running on Linux proper or if it's running on Linux that's actually Windows. The answer for that comes through the uname command that I gave you earlier. So if I just extract the interesting parts from the uname command, you will notice that for the Linux kernel release, it does have the Microsoft name that is appended to it, as well as for the version, it does append Microsoft. And that's something you will not get on a regular Ubuntu distribution that's running on a non-Windows machine. So inside your bash script, you can just have that check, assign that to a variable, whatever you want. Just if the release contains Microsoft, you know that you're running within a WSL environment. So that's always a good thing to have. Then comes the file system management. So for file systems, Microsoft embeds the Windows file system just as a mounted file system under /mnt. So you would get a tool then that helps you to do, you could do them, if you know that you have something under a C colon / program files, you could write your own routine that converts from that into a /mnt /c /program files. Microsoft does provides you the tool to do that for you already. It's called WSL path. And it works both ways. So you use -u to convert a Windows path into a Linux path, and W to convert a Linux path into a Windows path. It does pass through symlinks. So if you have a symlink that you created, in that case, so we can see on that second example, I am in my home folder on my Linux, in my Linux file system, and I have created a dev symlink to the mntc dev path folder that's on the Windows side then, so that actually points to C:dev. And I can then do what WSL path passing through the symlink, and it will convert that back into my Windows path. Why is that important? That's actually one of the tricks. This is how you want to be interacting. Normally, you will have your code checked out natively on your machine, so it will normally be checked out on the Windows side. Not necessarily, but you may have libraries or things like Visual Studio headers and standard lib that are on the Windows side. So in my experience, the easiest way to make those accessible without having to always do the mnt/c is to just have something like that and just do a symlink from your home folder back into Windows. The important thing, though, is it is not fully reversible. There is no access to the Linux file system from Windows. If you dig hard enough, you will find it, but you will most likely break something. It is hidden deep somewhere into one of the Windows system folders. But the idea is that as much as you get full access to the Windows file system from Linux, it will not let you access, for example, if I try to convert my home folder into a Windows path, it will not let me convert this one. Technically, everything within Linux is sandboxed. Yes, there is something here I'm not mentioning. Of course, one of the different aspects between Windows file system and Linux is the casing for file casing. So it is not mentioned here, but they have solved that by adding some metadata on the Windows file system. So you are actually able to resolve, let's say, if you have files on Windows which have a different casing, you are able to correctly map between the Linux and Windows file system. They have a set of rules, and you can override those with a special command, but I'm leaving this out. So, second step is environment propagation. So, one of the interesting aspects is only the path. When you start up a bash shell, it will forward the path environment variable to the bash environment, but that only the path. But why the path? Because one of the things that they want you to be able to do is be able to run Windows commands from the bash shell. They want us to be able to start Windows executables, so for that they need to know where these commands are. So they propagate the path environment variable and of course convert all the paths to the right MNTC format. So that really lets you do, you can literally start a command prompt, Windows command prompt from a bash shell that then lets you start a bash shell from the command prompt. Yeah, so like Exhibit says it, it's exactly when they put a car inside a car. That's the exact same idea. What if you want other environment variables from your Windows setup to propagate into the Linux side? You can do it. They provide a WSL-env environment variable for that. And just like your commands may also, a lot of the time, these commands will have paths in them. So you will have, in my case, breakpad bin there, because that's where the breakpad binaries are. These will be somewhere C, dev, blah, blah, blah. So that WSL environment variable is parsed by WSL when the bash environment starts up. And based on the flags that you pass, so here the /p that is at the end means it's a path. So WSL will convert those automatically. All right? So as you can see, once we're in the environment on Windows, they were like C:, and once you're on the Linux side, they are converted to MNTC. So these are just things you could do on your own, but they've just taken care of that for you. That makes it a lot easier. So once you have figured out how to map your paths, and once you have figured out how to map your environment, last step is integrating your Windows toolchain, which means when you're on Windows, you usually have your Visual Studio or MinGW toolchain. The one thing to be careful about here is you're like, oh, great, because I have Ubuntu, that means I have GCC, I have Clang. They surely are installed as part of the Ubuntu distribution, but those are the Linux binaries. They will create Linux binaries. So these are not the ones that you want to use if you want to create executables like .exe, right? So because we do want to build native Windows executables, you want to use the Visual Studio or MinGW. So you need to have a way to hook these up into the Linux environment. Typically from your bash script, you want to be able to say, hey, kick off qmake or whatever with the Visual Studio toolchain. So on Windows already, Visual Studio has a nice script that takes care of all that. It's the VCVars star, it's 3264.bat. It's a batch file, which we can call from WSL, because it will immediately convert that to a command prompt. But it will it will not even convert to command prompt. It will just run it as a Windows command and convert the IO. And unfortunately, that script only gives you either a command prompt or it gives you a, I don't have it here, that's fine. Or it just gives you basically a new environment, a new prompt, as if you had opened a new shell. But you cannot pass arguments to it. So what we would want to do is VCVars bat, qmake, blah, 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 .pro or nmake, but you cannot do that directly. It won't let you pass arguments. So for that, we actually had a bit of work to do. We came up with this little shell script called VCVars and run. It's a very simple shell script. It runs commands. It starts up the Visual Studio environment, passes commands through the command prompt arguments that lets you pass any command to a command prompt, and then basically runs these commands and returns at the end when everything is ready. So it's literally a wrapper to get access to passing arguments to this to the Visual Studio command. It supports, it's a bash script, so the commands are preparsed by batch. We will see how that makes things easier for you. And it supports forwarding with A or operators and so on. We do provide this, script on GitHub, so here's the address. Here's an example of how it works. Simple command. We just want to run a CMake, we just want to install a package with VCPKG, which I'm not going to get into detail here. So we define the command and even some arguments with, like, yeah, those could be environment variables, whatever. We get into the right folder. This is, by then, we're still all on the bash side on Linux. And then we kick off the second to last one. We kick off a batch file. So bootstrap vcpkg.bat is itself a Windows command that requires the Visual Studio compiler to be available for vcpkg to compile. So here, there's no argument. We just say run this command. And in the second case, we do have a little more complex command where we have the command itself, single argument, and then another argument that is itself expanded to many arguments. All right? And then you can do more complex stuff. You can do, here's an example of a QMake out-of-source build in which we want to pass several arguments, and our command starts to be pretty long. So we use here the facilities provided by the bash script language. And so you see the build command variable here. Every line in that command is an argument, so you can consider with separated by a space. So we run the qmake.exe that we have mapped from the Windows location, because this was a Q installed on Windows side. The -r, which means recursive, our qmake config, where our source, the last line is where our source folder is. And we actually combine both the qmake step and then the make step after that. And so you see, we mix up environment variables, expanded variables. The WSL path are subcommands that get executed, and the result gets put in there. So you can really stack up things fairly nicely without having to deal too much with trouble. And the last trick is when we run that command, that's the way you run it. This ensures, this is actually where most of the time was spent figuring things out. This last line is, and this format, this syntax in general, this is how we ensure that all the spaces are respected, that quoted arguments stay quoted. Believe me, there's like 3 levels of indirection going through command prompt and then going through the commands and bash and stuff. So this is actually the secret recipe to getting everything passed the way you want them. So this took a lot of trial and error to get right. Hopefully you won't have to go through the same pain. Okay, that's it for me today. I promised it wouldn't be, well, I guess that last slide was maybe a little bit much to digest. If you have any questions, I'm happy to take them now. Yes? There is a way, you just have to put it under mntc. So you can write the file from Linux, but have it stored on the Windows file system. Yeah, absolutely. Yep. It's okay, it's the end of the day, we're all tired.
If you're looking into your glass ball, how do you guess the chances that Microsoft will replace the Windows kernel with a Linux kernel entirely?
That's a very good, so look at my PS here. WSL2 is coming. So this really blurs the line even more. And to be honest with you, I'm myself kind of confused as to what they're doing now. I think, so one of the issues with this, the current solution, WSL1, is it works, except that it was extremely slow for some, especially for file system I/O. So when you use Git, for example, a simple Git status between Windows and Linux can take, 10 times, 100 times more, depending on the size of your repo, because of the translation they have to do between what the Linux kernel tells when it enters the Windows side. And they are very aware of that, and they know that they hit kind of a wall there. They are not able to solve that. So WSL2 is kind of their way of addressing this with a completely different architecture. So from the surface, it looks exactly the same. You still have your Linux bash shell. But now they actually ported, so a lightweight VM, so they essentially ported the whole Linux kernel to run through hyperthread, hypervisor, whatever. So it's essentially a Linux, but a Linux VM now, but a much better integrated Linux VM than, let's say, other products. So I'll just finish quickly. One of the differences, one of the advantages of that is that it will give you access. Now, the Linux file system is exactly the same as the Windows file system, so you can access them both ways. But it's just, yeah, you will have a different trade-off there. Go ahead. Mm-hmm. So yeah, the lines are blurry.
What about deployment in your company? You have set up such a nice VSL environment, installed a lot of packages there, GCC and so on, and then you want to spread it to the systems of your colleagues. Is there a nice deployment way?
Oh.
I currently prefer for this reasons to use a VirtualBox, create an OVA file, and give this OVA file away and import it on another machine.
Very good question, yes. So this is actually, in the very first slide I had, when I was presenting the issues, I was saying third-party libraries and stuff. One of them was also developer environments. And that's exactly, the way we do that is we have, it literally takes us 3 steps. We ask people to install Visual Studio, install WSL, check out our main code repository, and from there, all they have to do is a single build script, and the build script will go ahead and fetch everything that is needed. And we had that on Windows, and we had that script on Linux, where we even pre-package our dependencies and pre-build them and download that stuff from our own servers. And that's why we didn't want to, that's why we have a significant amount of scripting to get all that stuff run automatically, and we didn't want to have to rewrite all that stuff from scratch. So that's exactly one of the reasons why WSL saved us here, because now we have the same script that does all that stuff for both OSs. So yeah, it's literally 3-4 steps if you count checking out the source repository.
Another way that this has been approached, I'm not sure actually with VSL, is using cross-compiler so that you have a native GCC running or Clang working on Linux, which produces Windows binaries. Mm-hmm. Have you tried that, or what's your feeling? Would that be easier or harder?
It might work. I'm just a little worried about the all the stdlib and stuff. Yeah, having GCC and Clang able to create the Windows binary is fine. It's just that also includes all our third-party libraries and the stdlib itself, where I'm not 100% sure there. We haven't really tried it, and I sort of considered it, but this sort of worked faster and easier for us, so we're like, okay, let's. I would have been a little worried about what if something doesn't exactly work, and then at least we know it's the Visual Studio compiler and it's on Windows and everything works as it should. Yeah, especially when it comes to debugging and all that. Yeah, go ahead. And I think that will be the last question we take.
The last question.
So is it you use the Debian packages for deploying the Windows as well?
I didn't. Right? Yes, we had that. We ended up not going that route, but we had it as an experiment. And yeah, but I didn't include it in the slides because it was too much. But yes, with a little bit of hackery on the strings to pass for the distribution and the target. Yes, but essentially we already have our own apt. What is it called? I forgot now. Our own repositories for Linux, so it was just a matter of pushing our binaries, our Windows binaries there as well, and changing just that little screen for apt, for aptitude.
All right, thank you, Romain.
Thank you so much, everyone.